Okay, the next part, universal hashing. Well, the reason that we have to move on to universal hashing is no matter we are doing division method or multiplication method, well, there will always be a killer dataset which can kill your hash function. So what do I mean there? Well, the way I'm putting that as a killer dataset. So this is a term that I created by myself, and I think it means exactly what I wanted to say. Killer dataset. So for example, if we have the function k as k mode 10. So we have a hash table with 10 slots, and our hash function is whatever key we have, we are going to return the k mode 10. Okay, so in this case, how do we create a killer data set which kills this hash function? So we can do 10, 20, 30, 40, right? So in this case, and all those values will be sent to the slot 0. So there will be a lot of the collisions on slot 0. And this is not the only killer data set. So for example, I can do 21, 31, 41, 41, 51, etc. So as long as I figure out how to attack a hash function, and then I can easily create a killer dataset. I can do this for all the possible divisions. I can do that for all the possible multiplications as well. So as long as there is a fixed hash function, there is always a killer dataset which can kill this hash function and then bring a lot of collisions to the hash table. So you may ask, how can we fix it? How can we prevent our hash table to get killed by a killer dataset? The reason is, well, instead of relying on only one of the hash function, how about we create a lot of the hash functions, and that is a family of hash function. And when we initialize a hash table, and then at that time we pick a hash function, and then we are going to use that hash function in the remainder of the time when we need that. Okay, so instead of relying on only one hash function, we want to rely on a lot of the hash functions, and we pick one of them randomly, and then that is independent to the key we are actually going to store. Okay, so it's guaranteed that on average, we are going to have a good performance of the hash table. However, to do that, we do need a family of the hash functions that we can choose from. So this will be the topic we are going to solve very soon. Okay, so well, here's a formal definition of the hash universal hashing. So we define H as a finite collection of the hash functions, and those hash functions, of course, they map a given universe of the keys, and that is the U, and into a range of the slots, and that will be from 0 to m minus 1 if there are a total of m slots in the hash table. Okay, and H, well, and the next part, well, we ain't gonna take any hash function into the collection. We have to guarantee that for those hash functions, they're good ones. So H is said to be universal if for each pair of the distinct key x and y, and the number of the hash function which is gonna cause the collision between x and y is exactly h, the number of the hash functions divided by m. Well, if you don't like this definition, in other words, that is a better definition. That is, if you have just a random x and random y, and then you pick a random hash function from the collection of the functions, and then the collision is going to happen. The probability of the collision to happen should be exactly 1 divided by m. Okay, so if we have this kind of the hash functions, and then we have a collection of the good universal hashing functions. So let me give you a bad example. If we have a function, so function fbat, okay, fbat k is, well, return 1. So how do you like this? So this is a hash function. And how do you like that? So you may say this is a bad one. Why? Because it will always send the new item to the slot number 1, no matter what key it is, right? So that is a bad hash function. And if you go back to the definition here, so that in this definition, no matter what x and y we have, the possibility of having the collision on the hash table, what is that? It is not 1 divided by m. What is that? That is 100%. So no matter what kind of x and y we have, well, they are going to have a collision 100% guaranteed. So is that hash function qualified to stay as part of the universal hashing function? The answer is no, right? Okay, so, well, how do we create a big family of the hash functions? I'm not talking about how to design one very smart, very tricky hash function. Instead, I want to create a group or a family of hash functions. And how do we do that? And then we have to move on and define a few more things. So the number one, that is the prime number p. And the prime number p should be large enough and so that the possible key values will be lower than the p. Okay, p is a prime number, and if we know the range of the keys will be from 0 to 100, and then we want to pick a prime number which is higher than 100. So for example, we can pick a 103. I believe 103 is a prime number. Okay, and then, well, we define two sets of numbers. So zp will be all the natural numbers, well, lower than p, so from 0 to p minus 1. Okay, and the zp star is the non-zero natural numbers which are lower than p, so from 1 to p minus 1. Okay, so after defining that, and then we can define a hash function called HAB. So given a belongs to zp star and the b belongs to zp, so you can pick any number you want as the a and b. Okay, and then given a combination of the a and b, and then we can define a HAB like this. So ak plus b mod p and then mod m. So this will guarantee to return an integer value between 0 and m minus 1. And depending on the different picks of a and b, we will have different hash functions. So using this Python, well, it's guaranteed that we can have a big collection of the hash functions, and they are all good hash functions. They are all universal. And when we initialize a hash function, we randomly pick an a and a b, and that will be the hash function we pick and we use for this scenario. Okay, so this is the idea of the universal hashing. Instead of relying on one very good, very smart, very tricky hash function, we have a collection of reliable hash functions. And when we initialize a hash table, we pick one from this collection. Okay,